All right, guys, today's flipped lesson is over 4.7, triangles and coordinate proofs. Keep in mind this was supposed to be a lesson from last week, but with those hurricane days, we have now pushed it to Tuesday's lesson. Go ahead and get out a sheet of paper and let's take notes. Okay, the first thing that you need to add into your notes is the distance formula. Okay, the distance formula allows you to find, the length of any segment. The length of any segment. Now, keep in mind, vertical and horizontal distances can just be counted on a coordinate plane, but diagonal distances are going to have to be calculated on a coordinate plane. So, we're going to do those calculations with this distance formula right here. The next formula that we are going to work with today is the midpoint formula. The midpoint formula allows you to find the coordinate location of the middle of a segment. Okay, the midpoint splits the segment into two congruent pieces. The midpoint is always a coordinate answer. It's a location. So the midpoint is always a coordinate answer. You average your x's and you average your y's to find the middle location. Let's go ahead and get started. A right triangle has legs of 5 units and 12 units. We've placed the triangle in a coordinate plane. We've labeled the vertices, and now we're going to find the length of each side. So, remember, this length we can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. Now, this side, right here, I'm going to have to calculate. Okay, I can calculate that with my distance formula. So here's x1, y1, x2, y2. So the distance is equal to x minus x plus y minus y. And let's start to break this down. 12 squared is 144. 5 squared is 25. If we add those together, that's 169. And the square root of 169 is 13. So, we now know the length of all sides of that triangle. Let's look at another example. In this diagram, we're going to find the coordinates of L, okay? Given that these are congruent triangles, right? So this piece congruent to this piece. That piece is congruent to itself. And last but not least, those are congruent. So, if L is located right here, this would be the midpoint, right? It's directly in the middle of M and K. So let's calculate what L would be. Okay, it's going to be these x's average, x1, y1, x2, y2. So x plus x divided by 2. Y plus y divided by 2. 160 divided by 2 is 80. 80. So, 80 is the midpoint location. All right. Last but not least, when we're using variables inside of the coordinate plane, how can we calculate these distances? Well, let's take a look. Okay, we have this point is at 0, 0. This point is h units forward, 0 units up. So that means that the distance in between has to be h units long, right? You went over h, up 0. Then let's talk about C. Okay? To get to C, you went over h and up k. So this length is going to be that y value, or k units long. Last but not least, if I want to find the length of the hypotenuse, we're going to use the distance formula. Now let's identify our x1, y1, x2, y2. Let's get started. All right, y2 minus y1 squared plus y2 minus y1 squared. So this distance is going to be, let's see, h squared plus k squared. And there is no way for us to simplify this any further. So our final answer would be that hypotenuse, that question mark, is equal to h squared plus k squared. So again, this last example, instead of using actual numbers, we were practicing using variables. All right, that concludes our notes for 4.7. Go ahead and take some time now to work on the 4.7 practice problems, and we will answer questions in class on Thursday. See you then.